Hi everyone, today we are talking about linear equations word problems, specifically with equations. As a reminder, you do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we cover. Remember that you can also pause the video to jot down important notes, rewind to view information again, and fast forward if you think you already got it. Just be careful and make sure you don't fast forward too much or you'll end up missing out on something important. Let's get started with a review. So when we are looking at linear equations, word problems, it's very important that we know the slope-intercept equation because these equations will be written in slope-intercept form. So as a reminder, the y equals mx plus b equation, the m stands for the slope. You can also use m to remind you that that's how much you are moving. It tells you how much x and y are changing. On a graph, you would use rise over run or the slope formula. And the y-intercept b, you can think of the b as standing for beginning. It tells you the starting point. And it's going to be where the graph, the line of the graph, is going to meet up with the y-axis. So it's going to have 0 for the x and then your y-intercept value. Let's go ahead and look at some examples, but before you do that, make sure that this is in your notes. All right, so here's an example of the type of question that we can ask you when we're talking about linear equations or word problems. Okay, so for this example, we have Andre who wants to fill a glass tank with spherical marbles and then fill the remaining space with water. The variable W models the amount of water in liters Andre uses if he uses n marbles. Here's the equation, W equals 32 minus 0.05 n. They want to know what's the volume of each marble. Go ahead and pause the video and try it on your own first. All right, I'm a little confused on this problem, so I'm going to go ahead and draw what this might look like for Andre. He has a whole bunch of marbles. The W is the water in liters, and the N is the number of marbles. It doesn't quite look like it's in y equals mx plus b form. Remember the m stands for the slope. That's showing us how much it's changing or moving. And the b stands for the start, the beginning. That's your y-intercept. I'm thinking to myself, why is it, well, let me first put it in y equals mx plus b form. I'm just going to switch this around. So instead of the 32 in the front, I'm going to put it in the back. It's a positive 32, so it's going to be plus 32. This is subtracting 0.05, so it's going to be a negative 0.05 n. Okay, so this now tells me that the 32 is the start. We're putting water into a glass tank, so this is how much water was at the start. So meaning when there's no marbles in this tank at all, it's going to be 32 liters of water. And then for every marble that we add into the glass tank, he's going to use less water to fill up the tank, right? So that's why it's being subtracted from 32. That's the most water that could be in there. But if he fills up the whole thing with marbles, it's going to take away from the maximum capacity of water in this tank. So this kind of helps me make sense of what's going on. When you subtract from the start, that means that you're taking away from it. So the more marbles he puts in, the more water he takes away from the tank. This doesn't answer my question though. They want to know what is the volume of each marble. So the start, the beginning amount doesn't tell me that. So I'm going to go to my slope. Okay, my slope is negative 0.05. Okay, that tells me how much is changing. Remember, the marbles are going to change the amount of water he puts into his tank. So this works out. It makes sense. I'm going to use slope instead of y-intercept. But my slope needs a rise over run. Think to yourself, what's the number that goes on the bottom for your run when you aren't given a number? You should have said 1. If you said that, you're good. Any slope has an invisible 1 underneath. So we're going to call upon that 1 when we need it. So now this slope tells me that for each 1 marble, the volume of the water is going to go down by 0.05. So the marble is going to take up 0.05 liters, each marble. Okay, so in that case, the y-intercept was no good. Told us the beginning amount of water. But how much is it changing? That's the slope. Each marble is going to change the amount of water inside. And when we don't have a run, we're going to put a 1 there. Kind of rhymes with run, 1. Let's try another problem. In this problem, a charity organization is having a fundraiser. The variable P models the fundraiser's profit in dollars if N tickets are sold. A negative profit means the expenses exceeded the income from the tickets. They spent too much money on this fundraiser. They didn't sell enough tickets to earn money. How much money does the charity raise by selling a single ticket? Go ahead and pause the video and try it on your own. All right, so again, I'm going to start with my y equals mx plus b. Okay, with my slope and y-intercept. So I know here that my slope is 70 and my y-intercept is negative 1500. You should know by now that if the y-intercept is in the negatives, that means in terms of money at least, that that's the cost. This was a fundraiser, so the fundraiser cost $1,500 to even put on. It's in the negatives because they haven't earned any money. Nobody's bought a ticket yet. Okay? So this problem is asking us to figure out how much money the charity raised by selling a single ticket. We already know that the y-intercept doesn't help us. That is the beginning amount that this charity organization has. They're in the hole by $1,500. It has nothing to do with the tickets sold. Each time they sell a ticket now, that's going to change the amount of profit that they can have. So in this case, we're going to be looking at the slope. Slope is going to tell us how much it's changing. Okay? Now in this case, just like the previous one, my slope only has a rise. So I need to give it a run, 1. So this tells us here that each ticket that they're selling, each 1 ticket is going to cost $70. So it's going to take them a while to earn back that money that they put in and some profit. So again, your slope is going to tell you how much it changes. $70. Okay, let's try this last question. It says, ever since Renata moved to her new home, she's been keeping track of the height of the tree outside her window. The variable h models the height of the tree in centimeters, t years since Renata moved in. The equation is h equals 210 plus 33 times t. How tall was a tree when Renata moved in? Go ahead and pause the video and try it on your own. Okay, so we have y equals mx plus b, our favorite equation. We're either looking for slope or y-intercept in this problem. Here our slope, it's reversed. So our slope is 33. I'm just going to go ahead and put a 1 underneath it because we already know that we're probably going to use that if we use slope. Our y-intercept is 210. Let me read the question again. How tall was the tree when Renata moved in? So we want to think to ourselves, is this question asking us for the change or the beginning or start point? If you said that we're looking for the start, you are correct, okay? Because that's when Renata first moved into her new home. So that's the start. That's when she first started keeping track of the height of the tree. So we can tell that the tree was 210 centimeters tall in the beginning. And this is being added to 33t. So the slope tells us that every year the tree added on 33 centimeters. Started off at 210. Every year that since she moved in, it went up 33 centimeters. Okay? So those are 3 examples of how you can solve linear equations word problems when you're given the equation. Key thing is to think, which one are you looking for, the change or the start? Let me know if you have questions as you're working on these problems, and I'll see you in class.